Hello everybody and welcome to Metaverse Tech Sessions. My name is Max and I am developer on Roborace Metaverse platform. On the previous streams we generally did tests of features that was prepared for the mission 5 and we found bugs and on other streams we tested the fixes. So we talked about new services and we talked about overview and we did overview about the Metaverse platform. So okay, today it will be no tests, and today I want to talk about the core technology that is used for communication between vehicles on the track, between units on the track, between our services, and this technology is called V2X, vehicle to everything. So what is the V2X? Shortly, V2X is the future of vehicles communications. It has a lot of use cases, not only to communicate vehicles between each other, but many other use cases. And on this stream, I want to share some resources, some assets that I have on my PC, go through them and talk about the V2X technology that is used in the Roborace. Okay, let me share the screen. And I have some pictures from our test sessions. We will talk about them when I open it. So let me find the picture with where the V2X technology is described. Okay, I think this picture is good. So the V2X communication is the technology that allows vehicles to communicate with moving parts of the traffic system, and with not exactly with moving parts. It consists of several components. The first is vehicle to vehicle communication, when the car talk to other vehicle about its position, about orientation, about speed, and some other information that is useful to make a decision for safety and etc. So the second part is vehicle to device. So some cycle or maybe some other transport unit have the V2X model, and it allows these devices be a part of V2X communication. So the common use case when the cycle crosses the road, and maybe in the night, and maybe with low light conditions, the vehicle see this device, and it has information about this device, and for safety, the assistance on the vehicle can advise to the driver, or it may be some autonomous system to slow down and prevent the collision with the cycle, for example. Vehicle to pedestrian. For example, some peoples can have the V2X the V2X component on their cell phones, and the cell phone also emits the packets to the radio, and the vehicle can know about the pedestrian vehicle to home. Vehicles will act as supplement power supplies to the home. It's some extraordinary use case, I think, but yeah, it can be a vehicle to grid, smart grid controls vehicle charging and return electricity to the grid, and vehicle to infrastructure. This is the communication between the vehicle and the infrastructure units. It may be road signs, road lines, and some others. So at the moment at the Roborace, we are using vehicle to vehicle communication and vehicle to infrastructure communication. So how the V2X is working. At the moment, there are two major wireless communication technologies that facilitate communication for connected devices. One is called dedicated short-range communication, shortly DSRC. That is short name that is common in the USA, and the other name of this communication is ATS G5, and this name is most common in the Europe. And the second technology is CV2X. This technology is based on LTE. Yeah, this is like for G technology. Okay, we are using DSRC because it's stable, it is tested, and this technology is industry relevant and responds for our requirements and safety in range of communications and others. So let's go on and let me show yeah. So this is in junction, and you can see on this chair that all cars, all signs, traffic lights emits signals, and all of them knows about each others. So why do we need V2X? It's very interesting question. So basically, there are several levels of autonomous driving. So where the zero level is full human driving, and the sixth level is full automation driver, where at least there is no pedals or steering wheel in the car. V2X technology allows to reach second level, and the second level is a partial automation. It means that vehicle can control steering and speed, and keep distance from other car, center car on the line, and speed down for a stop. And V2X technology provides with information, with the data that allows artificial intelligence assistance systems to reach this level of the automation, the partial automation. So the next level is conditional automation. It means that the vehicle has capability to drive itself in some ideal conditions. I think we are near to it level on our our tests on our missions and our goal to reach the 5 level. Okay, let's go on, and let's talk. I think, yeah, maybe I don't have appropriate picture. So D3C is a physical level of communication, and it also separated onto parts on the software level. That is wave communication, where wave is wireless access in vehicular environment. That the wave is used in Roborace for car control, for monitoring, for V2X video, and the second one is ETSI CAM level. What is ETSI? ETSI is European Telecommunication Standards Institute, and it has the standard for communication between cars, and these messages are called CAM, that means Cooperative Awareness Messages, and we also use them for communication between gizmos and between cars. Okay, let's go on, and maybe we can find something interesting here. Okay. Yeah, V2X pictures. Yeah, there are some examples of road situations that can be resolved by V2X assistance, and this is blind curves, maybe overtakes, awareness about warnings, and etc., etc., etc. Okay, this picture about our boosted V2X. Let's talk about it a little bit later. It's the same. Yeah. Let's talk about the hardware of which the V2X consists. On the vehicle, there is onboard unit. Sorry. That communicates with roadside unit, and on this photo you can see like how Anatoly yeah, he installed the roadside unit on the ramp on the track. It was on the last summer when we had first Metaverse test on the ADM Raceway in the Moscow. And yeah, the roadside unit is a part that is located on the roadside, and this part is responsible for communication between the infrastructure and the onboard unit. Let me, yeah. This is the onboard unit. It has an Ethernet port. It has a port for the CAN bus. It has power port and ports to apply GNSS antenna. It has installed GPS sensor inside. But on the missions, we are using the external hardware that provides us with high precision GNSS data, OXTS sensor, and OXTS sends data to the OBU over the onboard network. Yes, here it is, the onboard unit. And onboard unit is located on the vehicle, and it sends information about vehicle position, its geo coordinates, information about your pitch roll, about speed, about heading to the other vehicles and to the infrastructure. Yeah, that's funny. That's funny car, and on this car during the test that was at the last year, we had installed onboard unit, and on the roof of the car you can see GNSS antenna. And yeah, this car was just for fun, for our first metaverse tests. Looks like I have a video, some movie. Yes, about our first metaverse tests. It's something like that. Other application, please. Yeah. So the onboard unit can be installed not only on the dev board or on the racing cars. It also can be installed on every vehicle, and every vehicle can be a part of our metaverse system. So the onboard unit on this movie, on this picture, is installed on this car, and it sends this data to the server, and we have a ghost representation of this vehicle in the metaverse. This it's virtual copy, and when we have this its virtual copy when this information is low latency, in our representation network we can render such images, such videos. Yeah, and yeah, you can see it on the Twitch translations during the missions where we have when we have the mixed reality representation, something like this. So what is on this video? On this video we can see two gizmos, and these gizmos not only presented in a representation network, they are like other vehicle for the real vehicle, for the devbot, and devbot has at every time has information about position, about velocity, and about heading of these objects. And these objects, when we decide that teams that the artificial intelligence is ready for real runs, these metaverse objects can be easily replaced with real vehicles. Okay. So what else? And let's talk about the metaverse and why do we need the V2X in the metaverse. So as you can guess, the V2X is the one of the transport layers, the medium for metaverse that provides information about all objects, if the objects in the real world or in the virtual world, it doesn't matter. They are all components of the V2X system. And Metaverse is... let me check this word. Is patented technology that provides this ability to create such mixed worlds. Somewhere in the documents I have a patent. Yeah, and let's open it and go through some basics of the metaverse. So this document is quintessential of the metaverse patent. So metaverse is a complex system of distributed software and hardware components interconnection by a low latency connectivity protocol into a real-time data network where information about real and virtual objects, events and condition is mediated through a shared world model. So at the moment, the V2X is this medium that allows metaverse objects, metaverse agents, share information about them to each other. The metaverse agents, this is real or virtual active objects capable to share their data and perceive other objects with maintaining our own local world models. Yeah. And here we have description. Why do we need V2X? Yes. The metaverse has three control data infuser. The DDS infuser, the development of our own DDS infuser in the progress. This technology is called Hive. We talked about it on the previous streams shortly. DDS infuser is some distributed data model that allows all components of metaverse agents know about each other and yeah. So at the moment we are using the V2X infuser that provides data infused logic for vehicle to everything communication. It means that metaverse agent, for example, the ghost car, it has its own physical model. The model is calculated, and the metaverse agent shares the information about itself, about its position to the V2X, and as following, as a result, the car has information about this virtual object. Yeah, and for our goals, we need boosted V2X stack. What does mean boosted? Generally, V2X communication in the standards for CAM communications, cavernous messages, means that information about cars should be broadcasted to the radio with 10 hertz frequency, but for our goals we need more frequent. Yeah, we need bigger frequency for communications because we need to calculate events such as collisions and real time. And for this option, we need to know about position of objects in the metaverse frequently. That that's implied that's implied by a standard. So also we have extended message format that let's talk tech. What do you mean? Let's talk tech, baby. Okay. Yeah, latency would be definitely annoying in a racing game. Yeah, but it's not a racing game. It's a mixed reality representation, and 100 milliseconds. It's yeah, this latency can be annoying maybe for racing game, but in the real world, so why we have such limit for this rate? Because I have a picture maybe. So because the V2X DSRC as a physical layer of V2X has limitation, has bandwidth limitation, and when we have high frequency, when we have a lot of objects, the radio can be overloaded, and that's why for some use cases we need low frequency. Okay. Makes sense. Yeah. And I have a picture when we had problems with the coverage on the Metaverse Control Center. We can paint the information about the coverage, where the green lines is an excellent coverage. When almost all V2X packets sent by the OBU is received on the server, and the bright color, orange or even red, it can be gaps. It means that in these parts of the track we have low latency, low latency information, and some packets was dropped during transmitting over the radio, and we can see it's on this picture. Also, on this picture we can see a roadside unit. This is Las Vegas Motor Speedway, and generally we had three. On this picture it is 4 roadside units for communication between the OBU and V2X. So let's go on, and let me open some Scratch tool, and I want to find how V2X how we do in V2X. Yeah. On which parts it consists during the tests on the real track, during the missions. So we have one on maybe 2, it can be 3, 5 or more on board units. OBU. So OBU, it's hardware about which yeah. We need to think about interference because currently we had tests only on conditions where there are no some obstacles for radio waves, but maybe in the cities it can be solved by installing roadside unit frequently and decreasing the transmission signal. Something like Wi-Fi 5 works. It has a low range of the data, and that allows to avoid interference of radio signals. Yeah, we have one or more onboard units. It's installed on the car onboard network. So OBU is connected to the OXTS sensor. No, not like that. Where's the eraser? So just white, maybe. Something bad. Pine tool, some bad pine tool. Yes. Let me erase. We have switch also. We have switch. And OBU connected to the switch. Also, we have OXTS. Speed code. It's hard to paint. It's speed code. Yeah. And also we have transcoder, video transcoder with GoPro connected. We will talk about it later, about this use case of using V2X. So OBU has its own antenna. It collects the data from OXTS sensor, from the video encoder, from the speed code and other components, and transmits it to RSU, to roadside unit, to all roadside unit. It's the information, the data transmits to all roadside units. And roadside units capture this data. This data is sent over the radio, over the DSRC, over the wave and YETSI ITS standard. And roadside units are connected to the trackside switch. track side switch. Oh yeah, it's hard to paint using the mouse. And from the track side switch, this data I consume it over the track side network by the mission server. And from mission server, this data is broadcasted to all other components. Also, we have vice versa communication between RSU and OBU. So the RSU sends information to the onboard unit. It is the commands to enable AI, to disable AI. It may be a safe stop command. Also, it can be a command to enable to disable video feed. And what else? Yeah, that's basic cases for communication between RSU and OBU. Okay. What information is sent to RSU? OBU sends to RSU the data about its state, AI state, information about battery, GIS data obtained from the OXTS sensor or embedded GPS sensor. What else? Yeah, that is the common info. And status. Okay, that is status messages and information about location in general. What else? That is one kind of messages. The other one, the messages that are related to our boosted V2X, and that is our feature that we are using V2X stack not only to communicate, not only to send commands to the OBU to obtain information about its position. Also, we send over V2X video packages. So the GoPro is connected to video encoder. Video encoder encodes this video feed using H.264 video codec, and these packages, these video packages, are sent to 1, 2, 3, 4 port of the OBU. And when the OBU receives the package from this port, it means that is the video port, and the software installed on the OBU, it's just called an OBU daemon, enriches the V2X package with video feed header. It's some bit in header. I forgot its exact position, maybe 16. And this package is sent to RSU. RSU just forwards this data to the mission server. And the mission server checks the header, and when the header has information that is video feed package, this package is transmitted, is forwarded to the media server. media server. So this case allows us to have low latency. It's about zero latency video feed from the car. Why do we need it? So for the safety, yeah. So operation team can decide when they are watching the video feed, for example, to stop the car. Okay. What else? Also, we forward SpeedGoat packages to the server that can read this data. This is some information about throttle at the moment, about lateral G. What else? Throttle, lateral G, GIS data. Generally, this data is very interested for teams. When they have this data, they can adopt the artificial driver for the car. They need this information about latitude, throttle, and some other. Yeah, ugly picture. So what else? Yeah. Let's see. Erase. Okay. What else? Yeah. I remember. We also use V2X to establish SSH connection between the server and IPv6 connection between the server and between the onboard unit. So the OBU and the RSU from the box have an ability to establish IPv6 connection between roadside unit and onboard unit. And when we want to establish this kind of connection, we just click to the toggle on the Metaverse Control Center. It creates a route from the server to the roadside unit, and the trackside engineer or team member can use the SSH to upload the data, to download the data from OBU, and we do not need to go to the pits to obtain this data. So the software on the DevBot can be updated when the car on the track and not connected to the service with the wire. That is some documents. Okay. Yeah, this is example of that is an example of video feed obtained using the V2X communication. This feed was recorded yesterday, maybe, or day before. The yesterday, it was the polymorph run. Polymorph is a team, one of the teams on the SIT car. Yeah, it is an SIT car, red car, and yeah, that was a fail. Something wrong in path planner. And yeah, what we have as a result, the smoke and the car is spinned out of the track. So this data is, this video is captured using the V2X technology. Yeah, what on this video. On the right side, we can see the video feed from the V2X, and on the left side, there are Metaverse objects that are added, are mixed to the V2X communication. So honestly, the V2X, yeah, nice drift, I agree. ATS pay a lot of attention to V2X, to security of V2X communication, because the V2X can be used by some bad people, some bad men, for the attack to the car. For example, the car moves along the road, and the car in some moment of the time starts to receive fake information about other vehicles, and car decides to change the path to some other path. So that's just kind of the attack, and the path can be changed somewhere to the forest, for example. Yeah, where the bad guys are waiting for this car. That's also funny video received using the V2X. I like to rewatch it. So it's a pity that no sound. We had no sound support when this video was recorded. Okay, what else? It's just some human-driven test run. With the ghost car, it's not very interesting. Yeah, and it's very funny too, but not funny maybe. The gizmos flickering. So that is the result. That is behavior. What my guess is for the shortest way around. Yeah, maybe. This picture is recorded in the simulator of some team. It may be ARG. And at this moment, we had issues with the V2X network. For some reason, maybe because of noises, we had overloaded V2X network. And as a result, the information about gizmos was sent with a delay, and on the server side we have the value that is TTL, for gizmos when we decide that gizmo is dead or it's alive. And the lag, the ping, so the frequency, yeah, of the gap between packages with Giza information was more than this value, and as a result we had this kind of flickering. They was appearing and disappearing. What else? V2X pictures. Maybe, yeah, that is the schema on which describe it how we do point of view video over the V2X network. That is the video source, encoder, onboard unit, roadside. So the video packet does this long path, but the latency in good conditions when coverage is green is about 0 milliseconds. Yes. What else? So maybe 7, 8, 9. Maybe you have some question? Do you have some question? No? Looks like not. Okay. And so at the end, maybe what is the development prospects of the V2X? We are using V2X, and yeah, we have a lot of experience of using it, and we have issues with the V2X. And the first issue is limited bandwidth of the V2X channel. Maybe in the prospect in the future, new standards of V2X communication will be developed, and at the moment the V2X over 5G networks in the development stage, and switching to 5G should allow us to have extended data rate, but it's not terabits per second or gigabits per second. It's just maybe 30 or 60. I always use 5G at the tech for the connected city and traffic. So unfortunately, I don't have any experience using 5G because there is no 5G in Russia at the moment, and as far as I know, it's not allowed. And yeah, but the missions you too. Okay, cool. But in the USA and in Europe, I think it's okay. It's everything okay with this next generation networks. So, and switching to 5G will allow us to use extended bandwidth, maybe low latency for the data. Maybe we can, using V2X, transmit video in better quality. Yeah, you can overload anything. Yeah, maybe. Yes, we can do it. Okay. Nice. Maybe something else. But yeah, V2X is not a medium. Yeah, is not a transport for this kind of data like video feed, really. So the V2X communication, it's just about communication between vehicle and other participants of the road, of the road scenarios, pedestrians, some devices, traffic lights, and else. And yeah, maybe in the future, and we are going to implement it. We want to leave V2X communication still fully road relevant, because at the moment we have our own extended format for the V2X data that has a tail. We expect that this tail shouldn't affect communication with other vehicles that uses the pure V2X standard. As far as I know, in the last year, Volkswagen Group, they developed the next generation of the Golf, and the Golf has V2X on the board. And maybe, and maybe the V2X, the Golf, is unable to see our objects, our gizmos, using the V2X network, because maybe for some reason the packages will be rejected, like some fake information, like corrupted data. But we on the Metaverse Control Center, I think then that we can see this car that have installed V2X components on board. Yeah, yeah, we had this idea to ask them. Maybe in the future it will be competition between Volkswagen or maybe Yandex car. By the way, I don't know what does the Yandex use V2X on their artificial driven cars. It will be interesting to have a competition between DevBot and Yandex car. Yeah. They have it on board. Yeah, I think that they use it because V2X it is not only V2V communication. I think that in the Europe there are plenty of road signs, road lights that has installed V2X components. So the V2X is very young technology, and in the future, when the V2X will be on major part, on big, more on the half participants of road moving, it will be more use cases for this, for V2X, I think. Yeah, I think that at the moment it is this technology is not distributed all over the world. Okay. Maybe you have. So let me check questions on the YouTube. Maybe we have some of them. Unfortunately, there are no questions on the YouTube. Okay. Yeah, I agree. It will be definitely more useful. Yes. Yeah, it requires re-equipment of the road infrastructure. I think that V2X networks will be developed faster in the Europe or in the USA that in other countries. And yeah, not in Russia, I think. Okay. Okay, and as the summary. There is no question. No questions. And as the summary, we are using V2X as the transport for data of real objects like cars. We have DevBot and Robocars on the track, and we mix our own generated objects to the V2X. And this technology, yeah, it's called Metaverse, allows to create some extreme scenarios for testing self-driving cars. And these scenarios that are implemented with virtual objects maybe sometimes cannot be safely implemented with the real object. Using Metaverse, we can easily mix pedestrian to the V2X network and train artificial intelligence to avoid the collision between the car and the pedestrian. And yeah, we are using road relevant format for this communication that is called Yetsi ITS, cam messages. And yeah, what else? So maybe something, yeah, that is just roadside unit by Corda Wireless. We are using their hardware. So, okay. If there are no questions, I think that's enough for today. We have a briefly talk about the V2X, about how we are using V2X in the Metaverse. So yeah, what's the smile? In the future, we are going maybe for next season. Yeah, it's very interesting for some auditory. I agree. We are using V2X to mix objects. To add objects in the view of ADS driver, but in the future and at the moment that is on the development stage, we want to mix virtual objects not only to the V2X, not only to the radio, but also to other sensors, to the computer vision. It means that the car will have some rendering engine on board and information about yeah, so wheel-to-wheel vehicle competitions also in our roadmap, and I think the first such first competition should be very interesting. Yeah, and I hope it will be very interesting. So, and continuing speaking about the Metaverse, the objects will be also added to the computer vision, to the leaders, and other sensors of the devbot of the vehicle. It will be, I think, next generation of autonomous driving cars. Maybe it will be Metabot with the rendering engine on board. We'll install it. Yeah, so I think that's all. Or maybe more questions? I am waiting. Oh, the sun is shining to the camera. No more questions? So, okay. Enjoy the sunset. Yeah, I think the Friday is a good day to enjoy the sunset. And That is a good word to stop the stream. And okay, goodbye. I will enjoy the sunset today.
It's the underground of motorsports. First, we challenge the idea of having human drive.